Hello, everyone. Welcome to the webinar, Alternative Textile Fiber Innovation, Achieving Performance, Cost, and Impact Goals. My name is Yuan Yu, Senior Director here at Lux Research, and I will be moderating today's session. Presenting today is my colleague, Tiffany Hua, analyst here at Lux. Now, throughout the webinar, you can type any questions you have in the questions box on your screen, and time permitting, we will answer all the questions that we can. In the event your question does not get answered, please do not hesitate to email it to questions@luxresearchinc.com, and we will get back to you shortly. If at any point you experience technical difficulties, such as a frozen screen, simply refresh your browser and check that your internet connection is strong. Now let's jump into the presentation. Over to you, Tiffany.
Thanks, Yuan. Hi, everyone. Thank you for joining the webinar. Today, we'll be talking about alternative textile fiber innovations, achieving performance, cost, and impact goals. So for today's agenda, firstly, we'll go over the current state of materials in the textile industry. Secondly, we'll go over the overview of alternative textile fibers, including synthetics, man-made cellulosic fibers, and protein fibers. And then lastly, we'll go over key takeaways. So firstly, we'll go over the state of materials. And so the first figure that I want to show is from the Textile Exchange Materials Market Report, which gives us an overview of the global textile fiber production over the last 50 years. And so what I want you to really look at is the green, which is polyester, and then also cotton in teal. So polyester, as you can see, really has had an increase since the 1990s, while cotton has had a steady pace over the last 50 years. But what has polyester done for us is pretty significant and quite noticeable in the last, let's say, 3 decades. We've seen the rise of fast fashion, the rise of high-performance sportswear, and my beloved athleisure. And so a lot of these synthetic materials, polyester, polyamide, spandex, have really enabled new markets to arise. But that has also come with a lot of takeaways or disadvantages. Today, we're seeing the rise of concerns such as microplastics. Textile waste has become a major issue. There are also other concerns like land use, toxicities, etc., that the public conscious is being increasingly aware of. And so regulations and brand commitments are also arising to really push the direction of textile fibers towards circular and low impact alternatives. And so there's a basis and driver for alternatives, but really it's the question of can they really compete with the current textile fiber production that we see here today? And so another thing that they have to really contend with is this geographical disconnect that we see between the production of textile today and then the demands and regulation that we see here today in the West. So since the 1990s, a lot of the textile production has moved towards the West, or sorry, the East, in terms of China, India, Bangladesh, Vietnam. Meanwhile, a lot of these large brands such as Zara, H&M, Nike, Adidas, they're mainly focused, on Western markets and headquartered also in the US and Europe. We're also seeing a lot of regulations emerge. So one is the Eco Design Directive. Another one is SB 707 in California for, extended producer responsibility and recycling of textile waste. So with this geographical disconnect, we have to understand how alternative textile fibers will play in this, let's say, industry's dichotomy, where they're going to have to understand the production while trying to meet the consumer and regulation demands. But we're still seeing major interest in alternatives, and investors are also, putting the money into this industry. So what we've done here is track all of these investments we've seen over the last 15 years, and we are still seeing an increase. In 2021, in 2022, you'll see a spike in orange and purple. That's really going to be due to 2 companies in particular For the orange, it's going to be Spiber, which has a couple hundred million in funding. And then also in purple is LanzaTech, which has also had a couple million or hundreds of millions in funding that year. And so even if you take away that spike of funding, you're still going to see an increase in funding in alternative textile fibers. So we have regulation, pushing forward alternative textile fibers, investments, also pushing forward textile fibers. But we're also dealing with this, textile industry supply chain disconnect. And then in addition to the current market of synthetics and other performance textiles that they have to compete with. So how do we move forward with alternative textile fiber innovations, and how are they going to succeed? So in this next section, we're going to give an overview of synthetics, man-made cellulosic fibers, and proteins. So first off, I want to give a broader overview of our taxonomy. So specifically, we have 7 categories that we've accounted for this technology topic. To simplify this area, we're going to break it up into 3 areas. So synthetics, cellulosics, and then protein-based fibers. So we have done a pretty extensive view of alternative textile fibers in terms of startups and emerging startups in our technology hub and through a technology landscape. So to really account for all of the innovation we're seeing in this presentation, what we're going to do is simplify the startups in terms of performance, cost, and impact across these 3 types of fibers that we're seeing. So alternative synthetic fibers, man-made cellulosics, and proteins. And then we're going to ask, in terms of performance, can these fibers really match in terms of durability, elasticity, and strength? And then in terms of cost, let's ask ourselves, how does it compare to conventional fibers in terms of raw materials and processing costs? Are these technologies still in development, or are they commercially available? And then lastly, in terms of impact, let's ask ourselves, does this material have a meaningful environmental advantage in terms of CO2, textile waste, land use, water, and any other environmental issue? And so we'll simplify the ratings a little bit here. We'll use bad, sufficient, and good, represented by an X, an O, and a check mark. And we'll go over each of these fiber categories. First up, we'll talk about alternative synthetic fibers. So within synthetic fibers, we've broken it down into biosynthetics. So these are fibers that are typically equivalents made from plant-based sugars or oils, but this also includes novel biodegradable types of polymers, including polylactic acid or polyhydroxyalkanoates, so PHAs and PLAs. And then we also have in this category recycled synthetics. So any recycled input, such as plastic bottles, or typically or ideally textile waste, made either mechanically or chemically, turned back into textiles. And then CO2 derived synthetics. So any CO2-based chemical or polymer that has been converted into a textile. And this is probably one of the newer areas, CO2 derived synthetics, that we're seeing in this category. So let's go over what we see in terms of performance for this category in terms of biosynthetics, recycled, and CO2. We have a longer figure here that goes over each of the 7 types of fibers, but here we're focused on synthetics. And what I want to bring your attention to is really the performance in terms of tenacity and elasticity, and then in terms of impact, looking at biodegradability and carbon footprint. And so for tenacity, as expected, these synthetics are really going to match their incumbents. So, for polyester, that would be around, let's say, 40 CN tax, for polyester up to 80. So these fibers do have pretty sufficient or actually matching performance I think you'll see in biosynthetics, the low end is 4. That really accounts for any of the biodegradable PLA and PHA biopolymers that we're seeing. But overall, across these 3 categories, the tenacity is good and matching. The area that you see in CO2 derived synthetic textile fibers, I think the downside is going to be elasticity. And that really is just because there's not enough development for spandex based chemicals within this category. So there's a need for additional chemical pathways that unlock different types of materials within CO2 derived synthetics. Now, with that being said, I think the downsides of synthetics is going to be the non-biodegradability and the production of microplastics. Given that these are going to match the synthetics in terms of performance, they're also going to match in terms of, recyclability, which is a positive if, the infrastructure does get built, but then also in terms of its persistence and then microplastic production. The biggest advantage in terms of its impact is going to be the carbon footprint. Now, when we look at polyester in terms of the carbon footprint, that's going to range around 4 to 6 kilograms of CO2 equivalent per kilogram. And so you can see here in biosynthetics, recycled, and CO2, there is a pretty good reduction in carbon footprint. I think the area where you might see it jump would be in recycled synthetics, given that some of these processes are a little bit more energy intensive. But overall, in this space, you're still going to see a reduction in carbon footprint. Now we've covered performance and impact for synthetics. I think the thing that I want to do now is go over an example of what we see happening in this space. So there's a lot of recycled synthetic activity happening. I think one that I want to call out is something a little bit different, and it's going to be bio-based spandex. So this is a new innovation that is emerging onto the market. And it's been a long time coming, given that this technology developed by Genomatica for bio-based 1,4-butanediol has been in the works for, almost up to a decade here. And so this is really coming downstream to Lycra, a major spandex producer here. And this has really been enabled by Core. So Core is a joint venture between Cargill and Helm, and they're scaling up this bio-based 1,4-BDO that is a critical chemical for spandex. And so this is coming onto the market in early 2025 and throughout this whole year as well. And there's also another producer, Hyosung, which is a textile performance producer as well, high performance textile producer. And so we are seeing an increase in suppliers and providers of bio-based spandex this year. I think the thing that is still unknown about bio-based spandex is the consumer appetite and market demand. Now, these materials are going to be similar in terms of performance, but they're also going to be contributing towards microplastics. They still have to find a recycling stream. And the thing about this specific type of material is that it's corn-based. It's unclear if there's going to be any backlash in terms of its upstream material input, which is corn, and then also its any backlash in terms of downstream, let's say, microplastic production. The thing that is an advantage is 44% carbon reduction, but it's still unclear if that's, is a good enough pull for consumer appetite. But I think this is one to really watch, especially as spandex, it's a really critical material for athleisure and then any form-fitting type of material for stretch and comfort. And so regardless, the spandex market will increase. We'll see how much this bio-based spandex can really, cut into that. And I think the thing to really emphasize that the synthetic market or alternative synthetics has an advantage in is the accessibility and the drop-in capability to the synthetic textile production. this global sports apparel brand that we spoke to, they specifically said that we won't consider new textile fibers or materials unless there are at least more than two suppliers producing the material. So for bio-based spandex, that is an advantage. It is a area that will open up because of that bio-based chemical, scale up. And I think this is going to be really critical to see market adoption, just the availability. A lot of the other ones we're going to talk about later, they don't quite have the commercial accessibility that synthetics do, like biosynthetics and recycled synthetics. And so they're going to have a challenge there, while here, the alternative synthetics definitely have the advantage. And then when we go back to comparing synthetics in terms of performance, cost, and impact, we saw that performance does match in terms of incumbents. So it has a pretty good score here. I think the disadvantages really come at the cost and impact categories. In terms of cost, they're still being introduced to the market. There is still an expected premium of these materials. And then in terms of impact, there's still concerns with microplastic production and also textile waste, given the lack of recycling for spandex or in other synthetics currently, and so we gave it a sufficient here. And our next category, alternative man-made cellulosic fibers. Within this category, we include recycled man-made cellulosic fibers, biomass-based man-made cellulosic fibers, and novel and microbial man-made cellulosic fibers. For recycled cellulosic fibers, they're going to include materials derived from post-consumer materials such as cotton, viscose, or potentially, other types of cellulosic materials, textiles. For biomass-based cellulosic fibers, that's going to really include non-wood biomass sources, so agricultural residue, food waste, even orange peels. And then novel and microbial man-made cellulosic fibers. This is a new type of material or category that we're seeing, and that really utilizes bacteria and microorganisms to produce cellulose that can then be spun into these cellulosic fibers. And just something to note about this category, they're really serving to replace cotton and conventional viscose, lyocell, just with a better alternative with lower impact. With that being said, let's take a look at the performance. So let's take a look at tenacity, elasticity, and moisture absorption in particular. In regards to tenacity, a lot of these man-made cellulosic alternatives are going to be pretty much equivalent to, let's say, cotton and viscose. For reference, viscose is around 35 to 40 cn text. And so in terms of, let's say, recycled man-made cellulosic fibers, it's pretty sufficient. I'd say at the low end of 24, some are going to be weaker. And then at 60 on the higher end, some are actually going to be stronger. And we've seen some startups have a value proposition that they are a high performance, let's say, man-made cellulosic. And so you're going to see a mixture of performance in regards to tenacity specifically. I think the thing, like cotton and viscose, is that there's low elasticity. And so it's not going to be great for, let's say, a need for stretch. And that's, typical of these types of fibers. You're not going to use it for, let's say, high performance sportswear. It might be a better fit for home goods or loungewear, for example, which is a growing market, let's say for lyocell, tencel in particular. And then, of course, moisture absorption. There is some moisture absorption there, similar to what we expect of cotton and viscose. When we look at impact in terms of biodegradability and carbon footprint, I think this is where we are seeing some good metrics. Of course, like cotton and viscose, in some cases, there is biodegradability, and we've seen some studies that recycled man-made cellulosic fibers do degrade in a sufficient amount of time. And then they do have lower carbon footprint here, some as low as -2 kilograms of CO2 equivalent per kilogram. And then for biomass-based man-made cellulosic fibers, 1.5 all the way down to 1.5. I think the area that you're still seeing a high carbon footprint is going to be novel and microbial man-made cellulosic fibers. And that really is because they're still in the lab stages. It's still quite resource and energy intensive to produce some of these bacterial cellulose products currently. And so to move forward, we really need to see that step in the process really scale up. So then, the whole category can come down in terms of the energy intensity and carbon footprint. So as we move forward, that might come down. But given the area of development or the time of development, expect novel and microbial to be high. One example that I wanted to call out here is a biomass-based man-made cellulosic fibers. We've heard a lot about, let's say recycled man-made cellulosic fibers, let's say like the Renewcell or Circulose. I think one that has seen some success that I want to call attention to is orange fiber. And they're taking quite a unique approach that I think there's a lot to learn from. And so orange fiber is a lyocell textile fiber made from citrus fruit biomass. And they're an Italian company found in 2012. And I think what they've done really well is that they have set themselves up as a textile or a luxury textile in fiber. And they've done that by partnering with some of these renowned textile mills. So, for example, Tusuli di Sondrio, for example, and Lenzing, very well-known lyocell producer. And they've worked with downstream customers such as Salvatore Formaggio and H&M for limited collections. And they're quite a established type of fabric nowadays. If you look up orange fiber, it's a new type of fabric that is emerging. And I think what's really interesting is that they have really benefited from the novelty and regional ties in Italy that this company, can really take advantage of. And so I think the thing to learn from here is that partnering with the textile mills and making sure that you are targeting luxury with the right weavers, textile producers, that's key because craftsmanship, when it comes to that part of, the supply chain, is quite important to reach your end markets. And so Orange Fiber has done this in a very interesting way. I think the thing here is what is their potential for growth? Of course, this is a very novel and quite niche area and niche type of fiber. Lyocell is, increasing in terms of the total fiber production market share. And then in addition to that, viscose as well. As a competitor to that market, we're going to have to see additional scale up and then also, moving beyond Italy and seeing if they can use other types of waste sources or, take advantage of orange waste in other regions to make lyocell. I think the interesting thing about orange fiber is the novelty and the pull that it can bring to consumers downstream. And we've heard this also from one of the global performance apparel companies that we've spoke to. And they've put it here in a really interesting way. If we're paying that level of premium, every customer would also probably need to as well. Then we would need to tell a really good story that can justify the premium down to the consumer. So really, if the question is really, can this material that is being brought to market, appeal down all the way to the consumer? So in terms of impact and novelty, those are the really two things to see if the consumer can get that buy-in. And so in terms of the performance, cost, and impact scoring, I think the area that man-made cellulosic fiber alternatives really benefit from is the impact. I think the waste source that we've seen with orange fiber, and then the biodegradability, they do have a higher score in impact. I think the disadvantage is going to be in cost. A lot of these materials are going to be niche currently, and we're still seeing some, struggles in recycled man-made cellulosic fibers. So cost is still quite a disadvantage in this category. And performance, we're going to give it a sufficient score just because there is a lot of fluctuation and variability, but overall you can still expect some sort of sufficient type of performance tenacity in these fibers. And moving on to our last category, alternative protein fibers. So these are fibers that replace animal-based fibers like wool and silk. In some cases, we're also seeing a lot of companies shoot for spider silk types of fibers. So spider silk has been quite difficult to produce naturally, given that spiders are cannibalistic, and so we can't quite do the same sort of silkworm farming production with spiders. And so that's one area that we're seeing a lot of innovation in terms of fermentation, production techniques, and then synthetic biology to replicate the spider silk proteins to really get a high performance type of fiber. Spider silk has been said to potentially match the strength and, let's say, density of Kevlar and steel wires. So there's a lot of potential for performance for protein-based fibers. However, I don't think that that's quite what we're seeing in reality today. I'll say that this area is still in development, and so there is potential for that performance to increase over time. But today, I'd say the tenacity is quite low. As a reference point, polyester is around, let's say, 40 cNtex. 30 to 40 cNtex. So there's still more work to be done to get to, let's say, Kevlar type of tenacity. And given that, man-made protein fibers are, let's say, made of proteins, there is a biodegradability aspect to it, which is good. I'd say a lot of some of these developers are trying to replicate wool. And so biodegradability, that natural aspect, is important for these types of fibers. The thing to note is that they're going to have a higher carbon footprint, given that they're still in development, given that a lot of these technologies rely on fermentation or synthetic biology. There is a high cost of, raw material inputs like sugar, but then also the processing involved. For reference, again, polyester is around 4 to 6 kilograms of CO2 equivalent per kilogram. But something like wool is actually higher, so around like 15 kilograms of CO2 equivalent per kilogram. So you could say it's comparable to wool, but definitely on the higher side. And so that's the performance and impact that we're seeing currently for proteins. I think one example that I want to call out to you is Spiber. Spiber is actually quite interesting because they initially targeted spider silk. That's kind of reflected in the name here, but they've actually moved away from spider silk specifically in terms of protein production, but more towards something more like wool, a wool-based protein or wool-like protein, and they have produced that under the name Brood Protein. And they're a company that has gained a lot of investments over the years, in total more than $800 million in investment. And so they have a lot of money to make this high-tech, fermentation, protein-based fiber a reality. I think that the thing that we're still running into is low production. You can kind of see in terms of the cost of these materials. We estimate from some of these product releases that their specific brood protein costs around $10 to $100 per kilogram, and even upwards of that. They are making a lot of clothes actually with producers though, or brands. Burberry, I think Kering is also another one, Goldwyn, Woolrich. So they are making an impact into the market. I think the thing is that it's still low volumes. Their typical textile composition is around 12 to 60%, and often mixed with either cotton, wool, silk, cashmere, or synthetics. And so the thing that I ask about Spiber is it going to be able to move away from, novelty and luxury markets? What they're really going to have to depend on is their scaling operations for, let's say, fermentation of their brood proteins. And this is something that we've seen failure after failure in this space over the last, let's say, decade. This company is probably the most mature and has the highest scaling capacity currently. And so this is one to watch to see if technology improvements can push this to scale, but it's going to be quite challenging here. And just something to close out this section with is a quote from a global sports and apparel manufacturer. We've heard from this manufacturer. I don't know whether any premium is acceptable at all. The goal should be to close the gap. And I want to reflect on what we've seen with Spiber. Spiber is a very, very high cost type of material. And not all producers, especially mass market apparel manufacturers, aren't going to be able to access that type of material. And so, a lot of these types of fibers, they're really only going to be accessible or geared towards luxury markets. And I'd say for mass market, really, it has to do with cost parity and then also scaling up a low cost process that has a lot to do with it. And so to summarize this category, I think this category struggles because it is a little bit earlier stage. The performance definitely needs some work. It can get almost up to the polyester, the tenacity of polyester, but the cost is significant at its stage in development. And the impact, still a very high carbon footprint, is biodegradable, but still that carbon footprint is much, much higher than the typical average. And so here, there just needs to be more development for us to see any increase in ratings. And then to summarize with our key takeaways. So as we just seen in our, let's say, figure of our ratings here, there's no solutions that checks all of the boxes. I think the area that we've seen, the most advantages is going to be synthetics. They are a solution that does match current existing incumbents. They also have more potential to expand with the, recycling technologies, the scale up of bio-based chemicals, and then they're also quite favorable in terms of extended producer responsibility, recycling schemes that prefer recycled or recyclable synthetics. And so, out of all of the three categories, we're going to see synthetics have the most near-term impact and near-term growth. For other categories, that opportunity is really going to be restricted to luxury segments. They're going to have to be able to handle a higher cost of alternative textile fibers that really appreciate the novelty and impact of these fibers. Again, mass market adoption is really going to depend on cost parity. Some of these companies, as we saw with the quotes, they really are looking for something that's comparable or has a very slight increase in premium. And so a lot of these technologies, they just need more development for us to get there. And then in terms of that R&D, there are some specific categories that it would be great to see development in. So alternative man-made cellulosic fibers in particular, given that there is definitely more processing requirements or upstream investments that could help performance and also production to reduce that cost. But protein-based fibers are very much underdeveloped. I'm curious if these types of fibers can open new markets, given that they are biodegradable and have some potential to be, high performance in terms of tenacity, as we saw spider silk. But currently, they're held back by current developments. And then also in terms of innovations to address waste and microplastics, there are opportunities for other types of fibers to emerge in the future. And so with that, as we reflect upon, alternative textile fibers, really consider which type of fiber would be the best when considering performance, cost, and impact. There's really not one solution that fits all, but as innovation moves forward, just keep in mind these factors. And thank you so much for attending this webinar. Back to you, Yer.
Thank you so much, Tiffany. We'll now be taking questions that any of you in attendance may have on the presentation. Please do type that into the questions box on your screen. Of course, as mentioned before, if we do not get to your questions on this call, someone from Lux will be in touch after the webinar. So as we kind of wait for some of the questions to come in, I have one myself. A couple of analysts from Lux were at a circularity conference earlier this month, and there's this tension between recycling and biodegradable options. Current regulations clearly favor recycled options over biodegradable solutions. Do you see this shifting in the next decade, and how should these brands that you've been speaking to prepare for that?
Yeah, I think currently that still stands. There's a lot of emerging regulations, EPR schemes that are looking for a minimum recycled content. I think the thing that we're seeing with biodegradable or bio-based options is still trying to assess the impact of microplastics in land use, which just needs more research to understand if they're viable options. Now, I think that the thing that could change is with more research there. Currently in the EU, there's an eco-design forum that's emerging that's talking about, which types of fibers and how do we design, let's say, better textiles. So that could influence, let's say, the types of textiles, whether it's biodegradable or bio-based or recycled. I think the thing that aligns with both options is, let's say, potentially biodegradable and recyclable options. PLA has, there are companies like, Corbion that have kind of touted that. There's still more research to be done to see if that's really a viable option.
Okay. We got a couple questions in the question box here, and I think one of them was really curious about your key takeaways. They ask, what will it take for alternative fibers to move beyond these niche collections and into actual mainstream production?
Yeah, I think the thing that we talked about at the very beginning is the accessibility, or let's say the drop-in functionality of fibers into the existing supply chain. I think when we talked about the very, very beginning in the intro, even the disconnect between the West and the East in terms of consumption and production. So how do we meet the production where it's at today? We really have to produce materials that match in terms of the material performance to what we have in the industry in textile mills currently. So I think that that's why some of these drop-ins, so drop-in nylons, drop-in polyester, spandexes, or let's say drop-in viscoses, they're going to be the best bet that's going to make an impact because they're faster to commercialize.
Excellent. Well, checking on the time here, that concludes our webinar for today. So thank you, Tiffany, for the presentation. To all of you in attendance, the slide presentation and this recording from the webinar will be sent to you all via email today. After leaving the webinar, you will be prompted to complete a survey on today's presentation, and we would really appreciate any feedback you may have to help inform and improve our future webinars. Also, in the meantime, please take a moment to check out our upcoming webinars on the Lux Research Inc. website. And thank you all for joining us and have a great day.